Okay, we'll solve some of the problems based on the properties. So first one, so solve delta is equal to 13, 16, 19, 14, 17, 20, 15, 18, 21. Okay, so anyway, we can solve using our regular techniques, but what I do now, I'll use the row column operations as and when required so that we can uh, solve it in a easier fashion. Now I can see that there is a difference of 1 between row 1 and row 2 and difference of 2 between row 1 and row 3. So I will write the row operations here. So row 2 is equal to row 2 minus the row 1, and I'll perform row 3 is equal to row 3 minus row 1. So this is going to give me an answer. First row is unchanged because we are not touching that. So 13, 16, 19. So row 2 is equal to row 2 minus row 1. So 14 minus 13, 1. 17 minus 16, 1. 20 minus 19, 1. Right? So we can perform the row operations and the value of the determinant remains unchanged. That's what is a property. So similarly, row 3 minus row 1 is not 1, sorry, 2. 15 minus 13, 18 minus 16, 21 minus 19. All right, so this is 2. Now, if you see a common factor anywhere, you can take it out, right? That's also is another property we studied. So 2 I'll take from the third row. That is 13, 16, 19, 1, 1, 1, 1, 1, 1. So there is another property which says if two rows or two columns are same, then the determinant is equal to 0. So 2 into 0, answer is equal to 0. Okay, we can solve this using the manual method and right by manually applying the rule of solving the determinant. We can apply that and we can verify this comes to be 0. All right. Next question. B plus C, Q plus R, Y plus Z, C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y. So show that this is equal to 2 times the determinant of A, P, X, B, Q, Y, C, R, Z. Using the properties, show this. Okay, we'll start from the left-hand side over here. So that is, we'll start with the delta. Delta is equal to A plus C, C plus A plus B, Q plus R plus P, P plus Q, Y plus Z, Z plus X, X plus Y. So now we can see that if I consider the complete one column, there are every variable is twice. So there are two B's, two C's, and two A's. Same thing, 2Q, 2R, 2Y, 2Z, 2X. So I can add them to get, right, the two outside somehow. So that's the idea I should think, right? So what I'm going to do now, I'm going to perform, say row 1 is equal to row 1 plus row 2 plus row 3. Linear addition or subtraction can be performed on rows or columns. So this is going to give you this is equal to, so everything gets added. B plus C plus A plus B is 2 times A plus B plus C. So I take a 2 outside. I have A plus B plus C. Same thing, P plus Q plus R and X plus Y plus Z. Everything has a 2 which I have taken out. Remaining, let us write inside. Okay, so I have C plus A plus B, uh, R plus P plus Q, Z plus X plus Y. Now, how to eliminate the terms? I have two terms here. Everywhere I have two terms in every element. I need to bring it into one sum. So what I try to do now, I can see that A and C are common here. AC, there is AC. PR, XZ there. One extra term is there. So if I try to subtract something, I may left out with only one term. So I'll try to apply the same concept for the third row as well. So if you do some row operations with the second row and first row, I'm going to retain only one term that I'm going to put it into second row. Same thing I'm going to repeat with the third row as well. So third row and first row do something so that only one single term remains, put it into the third. So this is what is a suitable operation I find. So R2 is equal to R2 minus R1, and similarly perform R3 is equal to R3 minus R1. So it's very clear we are not going to touch the first row. So let us keep that as it is. So this is A plus B plus C, P plus Q plus R, X plus Y plus Z. So C plus A minus B minus C. C and A cancels, only minus B left. Okay, do the same thing. We have minus Q left. Same thing you do, we have minus Y left. And in the third row, from the third row, AB goes, C remains, PQ goes, minus R remains, XY goes away, minus Z remains. Right? Now, I'll check. Can I bring single term in the first row? It is possible. Simply add. So that is R1 plus R2 plus R3. I'll put it into R1. So R1 is equal to R1 plus R2 plus R3. So that means it is 2 times. A plus B plus C minus B minus C is A. So A, I have P, and I have X. Fine. APX. Now you see minus goes out, minus 2. And again minus goes out. That is minus of minus becomes plus. You don't have to write that. So simply write B, Q, Y, C, R, Z. So that's the required answer. All right. The next question is 4x, 6x plus 2, 8x plus 1, 6x plus 2, 9x plus 3, 12x, 8x plus 1, 12x, 16x plus 2. If this determinant is equal to 0, calculate the value of x is the next question. So when we solve this, we get x is equal to minus 11 divided by 97. That's right. Let's move further. The next question is a square plus 1 AB AC AB B square plus 1 BC AC BC C square plus 1 magnitude, show that this is equal to 1 plus a square plus b square plus c square. Let's move to the next question. Okay, question repeated from old question paper. If a square 1 plus a cube b square 1 plus b cube c square 1 plus c cube, its determinant is equal to 0. Find the value of a into b into c is how much? Okay, so when we solve this, we get the value of a, b, c as -1. So we have this answer in